covalent bonding. First, okay, so this is your periodic table, so I just repeat again. So any element that is in group 1 will be +1, the charge for ion. Group 2 will be +2, group 3 will be +3, group 4 will be +4, then group 5 will be -3, -2, -1, and group 8 will be 0. Okay, so why do elements undergo bonding? So because the atom for most elements, they have what? Incomplete outer shell. Thus, they will either what? Transfer, or they will share electrons to achieve a stable electronic configuration. So meaning usually means the outermost shell should be 8, or if it's the first shell, it will be 2 electrons. Okay, so how do you derive the chemical formula of compound? So first of all, you have to write down the charge of each ion. After that, they will cross the number of the charge downwards, ignoring the sign. So let's go through some example. For example, you have carbon and chlorine. Carbon is group 4, so it's C4+. Chlorine is group 7, so it's Cl-. So when you combine them, it becomes CCl. Then now when you cross the charge, okay, just bring down the number. Okay, you bring down 4, this one you bring down the 1. So your final formula will be CCl4. Okay, another one, silicon and oxygen. Silicon, if you look at our periodic table, will be 4+, oxygen 2-. So when you put them together, will be SiO, but when you cross down the number, will be 2 and 4. But if they are even numbers, you can reduce them, so you get SiO2. Okay, last example, nitrogen and hydrogen. Nitrogen is group 5, so it's 3-. Hydrogen group 1 will be +1. Okay, so when you combine them, you get NH. Then when you cross the number down, it's 1, then this 3. So your final formula is NH3. Okay, next one. How do you draw the dot and cross diagram for covalent compounds? So first of all, we need to know that covalent compound consists of what? Non-metal atoms are chemically bonded together. So a non-metal atoms, right, will share its valence electron with another non-metal atoms. Okay, so it's between non-metal and non-metal to form a covalent bond. Okay, so take note, it's sharing. Okay, sharing of their valence electron. So steps to draw a dot and cross diagram for covalent compound. So first, you can write down the formula of the ions, which we did just now, and then obtain the chemical formula by crossing the charges. Next, you will draw the full structural formula of the compound form. Then you will draw the dot and cross diagram, then include your notation if it's required. So let's look at one example. CCl4. Okay, so carbon is group 4, so it's 2,4. Chlorine is 287. Okay, so it's 2, 8, and the last shell is 7. So if you see carefully, C4+, Cl-. When you cross, you get CCl4. So you take note that there's what? 1 carbon and 4 chlorine. So usually means the carbon will always be in the center when you draw your full structural formula. And then it's surrounded by how many chlorine? 4 chlorine. So you can spread it out, top and bottom, left and right. Okay, so let's take a look at the full structural formula. Carbon, if you realize, is 2,4. So you need what? You need 4 more valence electron, 4 more electron in the outermost shell. That's why you realize it will form 4 bonds. Whereas chlorine is 287. You need 1 more. So that's why each chlorine will form 1 more bond. So basically, a shortcut to figure out is what? You see how many more electrons it require, then it means it will need how many more bonds. You need 4 more electrons, you will form 4 bonds, means 4 lines around carbon. If it's chlorine, you need 1 more, so you will form 1 bond. So around each chlorine will be 1 line. Each line represents a covalent bond. Okay, so once you have the full structural formula, it will be easier for you to draw the dot and cross diagram. Okay, so this is the full structural formula, and then the dot and cross diagram will be this. Okay, so take a look at carbon. Okay, so it has 4 dots outside. Then once it bonded with 4 chlorine, right, you have 8. So just take a quick count: 1, 2, 3, 4, 5, 6, 7, 8. Okay, so once you have 8, it's stable. Let's look at chlorine. Chlorine initially has how many? 1, 2, 3, 4, 5, 6, 7. Plus 1 more carbon, from 1 more electron from carbon. Now you have 8, so it's stable as well. Okay, so after you draw the dot and cross diagram, just make sure you always count. Make sure the outermost shell is 8 to show that it's balanced, it's stable. Okay, and then don't forget your notation. Okay, so the dot represents electron from carbon, and then the cross represents electron from chlorine atom. Okay, so sometimes they might just ask you to draw the valency shell. So those inner shell electrons, you can ignore it. Okay, next one. So let's take a look in depth about covalent compound. So covalent compound, basically they can categorize into two groups. Okay, simple covalent compounds and giant covalent compounds. For simple covalent compounds, so typical example are water, carbon dioxide gas, and methane. So all these will form small molecules. But what about this group? Giant covalent compounds. The typical examples are diamond, graphite, and silicon dioxide, which is sand. Okay, all these will form giant structure, usually consists of atoms. Okay, not molecules. So let's take a look at the in-depth 4-point template. Okay, so I mentioned before 4-point template for answering the melting and boiling point questions. So the 4 points are what? You have to mention the structure first, what structure it has, and what bonding it has inside, and then what are the particles existing inside, and the energy level required. So when you are answering melting point and boiling point questions, make sure your answer consists of these 4 points to ensure a complete answer. Okay. Simple covalent compound. Okay, low melting and boiling point. Why? First point, structure. It has a simple molecular structure, or you can use simple covalent structure as well. Either one is fine. Okay. Then weak intermolecular force of attraction or weak van der Waals force of attraction between the molecules. So take note, the bondings are what? The bondings are weak van der Waals forces or weak intermolecular force of attraction. So it's denoted by the green color dotted line here. Okay. So this is one molecule. This is one molecule. Between molecules, they exist what? This weak intermolecular force of attraction. Okay. So it's very weak. Okay. So it exists between molecule and molecule. So take note, it's molecule. Okay. So since it's weak, means what? Little amount of energy is required to overcome these weak forces. Thus, it has a low melting and boiling point. So the example here that I show here is water. Okay, the explanation is the same thing when it's talking about CO2 or CH4 methane gas. Okay, so these are the 4 points. Make sure you have all the highlighted keywords in your answer. Next one, what about the conductivity and the solubility? So take note, simple covalent compounds are insoluble in water. Okay, cannot dissolve in water, but soluble in organic solvent. Next one, simple covalent compound do not conduct electricity in any states. Okay, why? Because there are no mobile charged particles. They don't have any ions or any electrons. Thus, that's why they cannot conduct electricity. So all the electrons are used for bonding. Okay, so no mobile charged particles. So sometimes they will ask you why it cannot conduct. Okay, so this is the reason. So you have to know why they cannot conduct. Okay, no mobile charged particles. Next one. What about giant covalent compounds? Okay, they have very high melting and boiling point. Why? Let's talk about diamond first. Okay, diamond, it has a giant molecular structure. Okay, each carbon atoms are covalently bonded to 4 other carbon atoms to form a tetrahedral arrangement. Okay, so if you look here, okay, so this is one carbon, it's surrounded by 4 other carbons to form a tetrahedral arrangement. Okay, they are strong covalent bonds. So since it's strong, you need a lot of energy to break these strong bonds. That's why they have a very high melting and boiling point. In fact, among as compared to ionic bonding, okay, covalent bonding is the strongest of all. Okay, so remember this. Okay, you also need to know some common uses of diamond. Okay, they are used as the tips of grinding, cutting, and polishing tools. So for this cutting blade, the edge of the blade, okay, the edge of the blade here is actually made of diamond. Okay, so the drilling one as well, the grinding one as well. Okay, so you have to memorize some common uses. Next one, what about graphite? Okay, so it has a giant molecular structure as well. Okay, within each layer, each carbon atoms are covalently bonded to 3 other carbon atoms. Okay, so let's take a look at these carbon atoms. One carbon atoms, right, is covalent 1, 2, and 3. Okay, to form what? Hexagonal rings. Can you see the rings as 6-sided shape, 6 sides. Okay, so between each layers, weak intermolecular force of attraction exists between the carbon atoms. So you can see between one layer and the other layer, right, they are connected by this weak intermolecular force of attraction, which is denoted by this black color dotted line. Okay, so within a layer is strong covalent bonds. Between layers and layers are weak intermolecular force of attraction. Okay, and since there are strong covalent bonds, a lot of energy is needed to break these strong bonds. thus it has a very high melting and boiling point. So graphite melting and boiling point maybe is it's slightly lower than diamond. Diamond is still be the highest. Okay. Some common uses. Okay, so graphite can be used as a dry lubricant. So you can use it to lubricate your machineries if you don't want to use oil or grease or any flammable liquids. Okay, graphite will not catch fire. Okay, but it's still slippery. Okay, next, it can be used as carbon brush for electric motors. So this is the carbon brush. Okay, so this one is the worn out one. This one is the brand new one. So if you take physics, you know how a DC motor works. You will know come across carbon brushes in your electric motor. The next one, inner electrodes for electrolysis. So as a chemistry student, you should know how an electrolysis process works. So inner electrode, it helps to conduct electricity. Okay, and then of course in pencil. Okay, so the first three are the more common uses of graphite. Okay, so take note of them. You might need them for your exam if they ask you for example or common uses of graphite. Okay, next one, and the electrical conductivity of giant covalent compounds. So first of all, giant covalent compounds are insoluble in both water and organic solvent. Okay, so they do not dissolve at all. Then for diamond cannot conduct electricity in any states. Okay, because what? There are no mobile charge particles in diamond. So all the electrons are used for bonding. So thus they are unable to conduct electricity. But graphite can conduct electricity in solid state, just like metals. Okay, why? Because each carbon atom, right, has a delocalized electron that is free to move. So if you remember the structure, carbon has 4 valence electron, but you only use 3 for bonding. So there's 1 delocalized electron. Thus, graphite is able to conduct electricity. Okay, so take note of this. They're next able to be used as a lubricant. It has something to do with the structure. So if you can recall, between each layers, weak intermolecular force of attraction exists between the carbon atoms. So since they are weak, little amount of energy is needed to overcome these weak forces. So for the layers carbon atoms to slide past one another. Thus, it is slippery and can be used as a lubricant. Bonding, ionic compound we already went through. So let's do an overview for the covalent compound. So simple covalent molecules and giant covalent compound. So the structure, simple molecular structure, but this is giant molecular structure. This is weak intermolecular force attraction, and it's between the molecules. But for this is strong covalent bonds between the atoms. So the melting and boiling point, this is low, but for giant covalent compound like diamond, it's very high. Then for this is soluble in organic solvent, but insoluble in water. For giant covalent compound, they are insoluble in both water and organic solvent. So covalent compound does not conduct electricity at all in any states, but for graphite can conduct. Other than that, for diamond, silicon dioxide does not conduct any states as well. Okay. Next, practice question 1. Okay, so take a look. Germanium is an element in group 4 of the periodic table. Germanium has a simple structure to macromolecular diamond. So first question, describe how a simple molecular structure differ from a macromolecular structure. 2 marks. How do germanium and graphite differ in terms of their electrical conductivity? And of course, germanium oxidizes slowly to form germanium dioxide. Okay, so you're supposed to draw a dot and cross diagram of germanium dioxide and showing only the valence electron. Okay, at part 1, what's the answer? Okay, so the difference between simple molecular structure and giant molecular structure. So first, a simple molecular structure consists of what? Weak intermolecular force of attraction existing between the molecules. But for a giant molecular structure, it consists of what? Strong covalent bonds existing between not molecules but atoms. So that's the main difference. Okay. Next one. How do germanium and graphite differ in terms of their conductivity? So germanium is a non-metal. So with that knowledge, you know that it does not conduct electricity. But graphite, it can conduct electricity. Why? Because it has delocalized electrons. So these electrons will help to conduct electricity for graphite. Okay, and of course the dot and cross diagram. Germanium is group 4, so it's a 4 valence electron. Okay, oxygen group 6, 6 valence electron. So you write the charge. Ge is 4 plus, oxygen is 2 minus. If you cross, it will be GeO, Okay, then when you reduce it 2 and 4, you can reduce become 1 and 2, so it's GeO2, okay, which is given here. Okay, then you realize that germanium need what? 4 more electrons, so you form 4 bonds, but oxygen need 2 more electrons, so you form 2 bonds. Each oxygen will have 2 lines, 2 bonds. Each oxygen will have 2 bonds. Okay, and then with this full structure formula, you can draw the dot and cross. Okay, so germanium will have 4. Okay, you will share 2 with oxygen, you will share 2 with oxygen. Okay, oxygen will share 2 with germanium, this oxygen will share 2 with germanium. And then of course your legend. Okay, so the dot represent electron from Ge, and then cross represent electron from oxygen. Okay, 1 mark. So just take note, show only the valence electron. So the inner shell, you can ignore it. Okay, question 2. Boron nitride, okay, Bn, exists in 2 physical forms. So one is a giant molecular structure in layers, but this is a in a 3-dimensional rigid structure. Okay, so first, suggest why boron nitride with structure A can be used as a lubricant, and then why in structure B it can be used as a cutting tool, okay, or drill bits. So first part, and third question. So boron nitride with structure A can be prepared by reacting with boron nitride with ammonia at high temperature. Okay, so draw a dot and cross diagram to represent the bonding in boron nitride. Show only the valence electron. Okay, it can be used as a lubricant. So the answer, it has a giant molecular structure, and then between each layers, weak intermolecular force attraction exists between the carbon atoms. So little amount of energy is needed to overcome these weak forces to allow the layers to slide over each other easily. Thus, it can be used as a lubricant. So emphasize on between the layers, there are weak intermolecular force of attraction. Okay. Part 2, why structure B can be used in cutting tools. Okay. Answer. So we emphasize the structure again. It has a giant molecular structure. Boron and nitrogen atoms are covalently bonded alternately. A lot of energy is required to break these strong covalent bonds. Okay. Thus, it is hard and can be used as cutting tools and drill bits. Okay, so in this case, the keyword is strong covalent bonds. Okay, a lot of energy is required. And then last bit, okay, draw a dot and cross diagram to represent the bonding in boron nitride. Okay, so boron is group 3, 3 valence electron. Oxygen, group 6, 6 valence electron. So boron will be 3 plus, oxygen will be 2 minus. When you cross it, okay, you get B2O3. So the structure is made out of 2 boron and 3 oxygen. So boron will need okay, oxygen will need 2 bonds, yeah, because you need 2 more electrons. So if you realize the structure, it will look something like this. Okay, so oxygen, it will form 2 bonds, so you have 8. This oxygen will have 2 bonds as well, so it will form 8. And then this oxygen will form 2 bonds, so you have 8. Okay, boron will have 3 with another 3 bonds, you have 6. Okay, so boron in this case is a little bit different because it won't have 8 to become stable, you will have 6 in the end. Okay, so with that, you just draw the valence electron. It will be something like this. So this oxygen have 6 crosses. You will share 2 from boron, so you have 8. This oxygen have 1, 2, 3, 4, 5, 6, 6 crosses, and then shared by 2 more dots. Okay, so you have 8. This is oxygen also have 6 plus 2 more become 8. So if you realize the boron in this case have 1, 2, 3, 4, 5, 6. You only have 6. Okay, 3 dots are originally its own electron. Then this another 3 crosses are electrons from other oxygen atom. And then of course your legend. Okay, so that's all. So don't forget to like, share, and subscribe. Okay, bye.